In this video, we're going to look at organic halides. We'll start with the functional group. Organic halides have a halogen attached to the parent chain. Halogen could be fluorine, chlorine, bromine, and iodine, and the branch name would be fluoro, chloro, bromo, or iodo. Let's move into some examples. If we look at this example right here, we can see that there are two carbons. There's a carbon here and a carbon here. The question is, which way am I going to number them? Well, since there's a tie between chlorine and fluorine, I'm going to go alphabetical and I'll go 1, 2, and then I will say 1, 1, dichloro, then 2, 2, 2, trifluoro, fluoro has an O right there, fluoroethane. Okay, so a fairly big name, just so that it doesn't interfere with my next name, I'm going to move it over right there. The next molecule right here, the parent chain is benzene, so I'm going to number it as follows: 1, 2, 3. I'm going to give bromo the lower number, so the higher priority. Even though they're both halogens, B comes before C in the alphabet, so that's the way I'm going to go with it. So 1 bromo, 3 chlorobenzene. In this structure right here, it doesn't matter if I label it from left to right or right to left, the priorities are still the same. So in this case right here, I'm going to write 1, 4 dibromo, and then I will write 2, 3 dimethyl, and then there's a double bond on the second carbon, so 2-butene. Okay, bit of a longer name there. If we look over here, the question is, do I start 1, 2, 3 from this end, or do I start 1, 2, 3 from this end? So am I giving the iodine priority, or am I giving the triple bond priority by giving it the lowest number? Well, we should give the triple bond the lowest possible number, and that's because it becomes, or rather it has a higher priority than iodine in the priority chart. Here's the priority chart, and you can see that triple bonds rank over halides in terms of priority, so the triple bond has to have the lowest possible number. And so we have to number it such that the triple bond gets the lowest possible number. Okay, so if I continue to number it, I've got 4, 5, 6, 7, 8, 9, and 10. And so now I will simply name it 2, 2, 10 triodo, 5 methyl, 3 decyne, YNE for the triple bond. So physical properties, organic halides tend to have higher melting points and boiling points for two reasons. Replacing H with a halide increases the number of electrons in the molecule and therefore the London dispersion forces. Halides may introduce polarity into the molecule due to their higher electronegativity. Okay, you can see two examples below in which you have a difference in polarity. Solubility of organic halides in water or other solvents depends on the molecular's polarity. So if it's polar, then an organic halide will dissolve in water, and if it's not, it will not. Let's take a look at reactions. The following reactions have halides as products. So these would be called synthesis reactions, or like production or producing an organic halide, okay, or preparation reactions. So how do we prepare an organic halide? Well, let's look at substitution in an alkane. We've seen this before, ethane and bromine. So ethane is CH3, CH3. We're going to have bromine, and we're going to say ethane and bromine are going to react in the presence of UV and heat And it's a substitution reaction, so that means that bromine is going to go onto the molecule and a hydrogen will come off. So I'll have this with one less hydrogen and there's one less bromine. And so over here, the hydrogen has come off and it's joined the bromine. And in this case right here, one of the bromines from Br2 has gone on. I will write the names underneath. Ethane, bromine, bromoethane, hydrogen bromide. We can also do substitution in benzene, so benzene and chlorine. So over here, I've got my benzene ring. Okay, and for this case, I'm going to show alternating double bonds. It is still a substitution reaction because what you need to remember is that on the benzene ring, we have a whole bunch of hydrogens. Okay, typically we don't draw them in, but they are still, in fact, there. And let's leave them here for now, just so we can see the substitution. Okay, again, this is going to take place, and it takes place in the presence of FeBr3. Okay, and then we will have chlorobenzene, because one of the hydrogens comes off and joins the Cl, and one of the Cl stays on. And I'm not going to redraw the other hydrogens. You know that they're there, and now I'm just going to write the names. Benzene, chlorine, chlorobenzene, and hydrogen chloride. Again, you can see in all of these cases, we are preparing an organic halide. So we're making an organic halide. All right, let's look at addition in an alkene and alkyne by halogenation. So we look at propene. Propene means that there's a double bond. So H2C, double bond CH, CH3, plus iodine, I2. Because there is a double bond here, double bonds are reactive, so there's no reaction conditions that we need to list here. And then we'll have right here H2C. It goes down to a single bond, CH, CH3. And because it's an addition reaction, the iodine is added directly to the molecule right here. Okay, and we have our organic halide. Propene, iodine, and 1,2-diiodopropane. Notice that we had a double bond, the iodine was added, and now we have an alkane. We can also do an addition in an alkene-alkyne by hydrohalogenation, so not halogenation, but hydrohalogenation. So propene, again, so H2C, double bond CH, CH3 plus HF goes to form, and then again, H2C, that double bond is going to go down to a single bond. You don't have to show this, for example. You could just put the two C's together. I'm going to show it to be a little bit clearer that it's no longer a alkene. And then we have to recall Markovnikov's rule. Again, Markovnikov's rule says that when you have a hydrogen that's being added to a molecule, you add it, if possible, to the carbon that already has more hydrogens. So my hydrogen is going to go here, and my fluorine is going to go here. Markovnikov's rule is also known as the rich get richer rule. Let me write the names. Okay, we have propene, hydrogen fluoride, and then 2-fluoropropane. Okay, the following reactions have organic halides as reactants. Well, you can have elimination with a hydroxide ion, so 1-fluorobutane. So that means I'm going to have H2C. And you know what, I'll not use bond, so CH2, CH2, CH3. And it's 1-fluoro, so that means I've got a fluorine right there. Okay, and then I have the hydroxide ion here. So OH minus, okay, and then I'm going to end up getting H2C, and I'm eliminating this right here. So a double bond is going to form, and then I'm going to have CH, we can see one of the H's comes off as well, CH2, CH3, okay. So let's think about this. I've got my hydroxide and an H has come off. So if I have hydroxide and an H has been taken off the molecule, well, you may have guessed it does in fact form water. And as you can see right here, the fluoride is no longer present. So the fluoride comes off as an ion. And much as we've seen before, the charge, which is 1 negative of the left side, is equal to the charge on the right side, also 1 negative. And we put in the names. 1 fluorobutane, hydroxide, 1 butene, water, and fluoride. Finally, we have substitution in benzenes using an alkyl halide. So we're going to have an organic halide reacting with benzene. All right, in this case right here, I'm going to show benzene, and instead of showing it with my alternating double bonds, I'm going to create the ring right there. Okay, and I'm going to say chloroethane. Okay, so that means that I'm going to have H2C, CH3, and a Cl is right there. This, if you will recall, reacts in the presence of aluminum chloride, and what it makes is it takes the benzene ring, one of the hydrogens comes off. Again, this is a substitution reaction, so a hydrogen is going to come off. The chloride is going to come off, and so we end up with HCl. The hydrogen came off, the chloride comes off, and then the ethyl group attaches to the benzene right there. We'll write the names. Benzene, chloroethane, ethylbenzene, and hydrogen chloride. Finally, organic halides are not flammable, so no combustion reactions occur. Thanks for watching.